Hi, I'm Toby Kaplan. For over 30 years, I was a classroom teacher and a mathematics coach, and now I work with Symphony Math. I'm going to show you a routine that you can use with your whole class, a small group, one-on-one, remotely. It takes about 15 or 20 minutes of your class time, and it works with all the content in Symphony Math. We'll have students make models of a problem, and then they think and talk and communicate the ideas they have and the questions they have. In this way, students are really constructing their own knowledge. They're trying to make sense out of what they see. We know that when students take ownership over what they're learning, it really helps their foundational numeracy be stronger. The content today is from Stage 13, Division. Now, division is something students are familiar with all their lives. They're dividing things up, food, treats, supplies, and they want to make sure they get their fair share. Equal share. Well, repeated equal groupings is the big idea behind multiplication and division. Repeated equal groupings builds on the parts to whole big idea because we start with the whole and we break it down into repeated groups that are all the same size. Throughout Symphony, they're basically using the same models. In this way, students can see a progression towards division in this case, because the models support the different operations. We're going to look at the grid model today, the array. In the array, students may recognize that they've been solving multiplication problems, and multiplication and division are inverse operations, so it's great if they make this connection. The models help support students' understanding, and we want to make sure that they can see the relationships among the numbers when they look at a model for division. You can find out more about the big ideas of division if you go to Stage 13, the stage overview in the scope and sequence. The materials today will be a grid, some interlocking cubes, some number cards, and we'll introduce students to a division sign. Here's how I would go about introducing a task for students. I would start by saying to students that we've been working on multiplication, and we've been using the grid model to help us see and understand multiplication problems. Today, we're going to look at division. Dividing things up is something you've had experience with in your lives. You divide up treats and supplies and toys, and you want to make sure that you get your fair share, or an equal amount. Let's look at this problem and see how a grid will help us make sure that everybody gets an equal amount when we divide something up. Here's the division problem we're going to solve. It says solve by making a model and completing the number sentence. 18 divided by 3 equals some number. Okay, it says that I have 18. Well, I counted out these cubes, so I'll make my model with a bunch of cubes here. Now these cubes are in a mess, but I know that I have 18 because that's what it tells me. I also know I want to divide 18 by 3. So I'm going to take this mess and start dividing it into groups of 3. If I organize it into 3 groups this way, it really helps me keep track in a much neater arrangement that I can count when I'm done. So I have 1, 2, 3 groups, and I'm going to make sure I divide the cubes evenly into my 3 groups as I go along until I'm done and I have no cubes left. I've got it organized by rows. I've got 1, 2, 3 rows because I'm dividing by 3. I have 18, I have 6, 12, 18 all together. And I can see 1, 2, 3, 4, 5, 6, that's a row. 1, 2, 3, 4, 5, 6, same number. 1, 2, 3, 4, 5, 6. I can see that each row or each group has 6 in it. Do you have any questions? I'm going to stop here to give students a bit of a break from my voice and also to give them a few moments to just observe and to take a look at this model. I'm going to be doing 2 more models and I don't want to overwhelm them. If they have questions, great. If they don't, that's okay. We're going to keep going. Now we're going to take this cube model and put it on a piece of paper like you would see in math class. I still want to make a grid arrangement. So I know somewhere in here I must have a total of the 18 that I'm going to be dividing up. So I've got 18 altogether. I was told that I was dividing by 3. So let me mark off 1, 2, 3 rows and label this with my 3 because I want to keep track of what I'm doing and how many rows or how many groups I have. Then I took them, all the cubes, and divided them until there were none left. As I fill in the squares on this grid, I'm going to need to keep count till I get to 18, as long as I know that I deliver 1 to each group at a time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, I have 18 squares filled in. I have my 1, 2, 3 rows that I divided by, and I have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6 in each row. I'll label that. There's my grid arrangement. And the last thing I need to do then is fill out the number sentence. Okay, it told me that I had 18. Here's my 10 and 8 more. I knew that I was dividing by. This is the sign we use to show dividing by. I divided by 3. That's what it told me. And it equaled some number. Well, I think we noticed that when we divided by 3, we end up with 6 in each row. We read this as 18 divided by 3 equals 6. What do you notice? What do you wonder? When we ask students to notice and wonder, we're encouraging them to take a few minutes, think to themselves, and take a look. What do they observe? What do they want to know? How are they making sense of these models? Let them think quietly for a while. If their comments at first aren't mathematical, that's okay. I mean, if somebody says, well, we had some purple cubes and then there are checks, you might say, yes. Well, what do you notice about the purple cubes and the checks? How are they the same? As students are thinking, here are some questions that you can ask them to talk about when it's time for them to share their ideas. Where on the grid do you see the whole amount that's being divided? How do you see equal parts on the grid? Is the grid model for multiplication the same as the grid model for division? How are they the same? How are they different? How does the grid help you solve a division problem? While students are talking and sharing their ideas, don't feel that you have to comment on everything they say. You want to encourage students to listen to each other and comment on each other's ideas. Sometimes when students hear things from their classmates, it's expressed in a way that's different than you would express it. It may resonate more with the children. You also don't have to correct, you don't have to judge. Allow students to voice their observations. You may be surprised by what they see. They may notice how multiplication and division are both implied in that grid. As students are talking, after a few minutes, you can sum it up and start a second problem with them. This problem will be more the fair share or partitioning problem. We won't know how many groups we're going to divide a whole into. Kai has 20 extra animal crackers. He wants to divide them equally with some friends. He gives each of his friends 5 animal crackers. Well, how many friends are going to be sharing the animal crackers? All right, with this problem, let's see what I know and what I need to find out. It says Kai has 20 animal crackers. All right, here's my 20 animal crackers. They'll work for today. In this case, I don't know how many friends are sharing them. That's what I need to find out. But what I do know is that his friends will each get 5 animal crackers. Again, if I arrange this mess into neat rows, then I can solve the problem. I'm going to make rows of 5 animal crackers because it told me that's how many each friend is getting. Since I have 20 animal crackers here all together, as soon as I use up all my animal crackers in rows of 5, I know I will have divided them all up. Okay, so I have rows of 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes, 1, 2, 3, 4, 5. All right. I have 20 altogether. That's how many I started with. Now what I need to see is how many rows of 5 do I have? 1, 2, 3, 4. 4 rows of 5. I had 20 animal crackers. Each friend got 5, and 4 friends would be receiving the animal crackers. Do you have any questions? I want to give students a break from my voice and time to think about what they're looking at. Does it make any sense to them? They may have questions, and if not, I'll just go on. Either way, it's okay. Now I want to make a grid model that matches this cube model. This is often what you see in class. In this case, I knew that Kai had 20 animal crackers, which right now will be represented by the squares on the grid. I also knew that he was giving 5 to each friend. What I didn't know was how many friends would be receiving the crackers. So I'm going to be going on rows of 5 until I run out of the 20 animal crackers I'm dividing. I better count by 5s to figure this out. So here's a row of 5, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right. Here are the 5 animal crackers that each friend received. 5, 5, 5, 5. In here are the 20 that he had all together. And now I've got to count up to see how many friends got his animal crackers. 1, 2, 3, 4. 4 friends. Always want to label it so I remember and keep track of what I'm doing. 4 friends each received 5 animal crackers out of the 20 Kai had. The last piece of this is to finish the number sentence. Now, I might want to start here by 20 and say 20 divided by some number. Oh, that's not my answer though. What I want is how many friends were getting the crackers. I can't say 20 equals some number divided by 5. That would not make any sense. Let me put my 20 over here. I had 20 animal crackers to begin with. We divided them, there's the sign for divide, by 5. And what we had to figure out was how many friends were each getting 5 animal crackers. We determined 4 friends got the 5 animal crackers. So we say 4 equals 20 divided by 5. It's a lot to digest 3 different arrangements or 3 models or 3 ways of representing one problem. But I want students to be thinking and comparing what they see in one model versus the other. What do they see in the number sentence? Does it make sense to them? So I'm going to give them a few moments to think to themselves before they share. Again, I don't have to talk or answer everything that they say. I want to encourage them to listen to each other. And here are some questions that I can use to nudge their thinking. How does the grid and the cube model help you understand a problem? We didn't know how many children were sharing animal crackers. We did know they each received 5 animal crackers. What did we do to find out how many friends there were? How does the grid arrangement help you see division problems? After you've had a conversation with your students, let them know that you know they're ready to do tasks on their own. You will find an abundance of tasks if you go to the guided practice, stage 13 in Symphony Math. You can also pull up the demo mode and click on anything in stage 13 and project onto your smartboard. Tell students you want them to make a model of the problem and a number sentence of the problem, and they should be ready to talk and share and communicate what they see and what they're thinking about. Students will often surprise us. They'll say things and observe things that we wouldn't otherwise expect them to. They may see and say things before we have to tell them. After students have had 10 or so minutes to work on their own, it'll be time to bring them together, have some conversations, ask the same questions we've been asking, and then you can do a debrief. You want to let them know that we used a grid arrangement today to see and then solve division problems. You might say some of you observed that it's the same grid that we use to solve multiplication problems. That's because multiplication and division are very closely related. We also asked a lot of questions, and it's good to ask questions. That's how we learn. As students go back onto Symphony Math Stage 13, you can monitor their progress by looking at your dashboard. If you go under the Use and Progress page, you'll see red, yellow, and green informative icons, and when you click on any of them, they'll let you know the particular tasks students could do without any problem, the ones they hesitated on, and then the ones that they were still stuck on. This is a signal to you that you might want to take some of these students and continue to do some offline work of model making and talking and listening like we did here.